Welcome. So this question says a mass of 12 kilograms, mass A is 12 kilograms and mass B is 1 kilogram. These masses all are located in deep space with a separation of 2 meters. And then it says, what is the magnitude of the force? With what magnitude does the force does the 12 kilogram mass exert on the 1 kilogram mass? So let's visualize it. So we have the 12 kilogram, we'll put the 1 kilogram above it. It's just an orientation that seems convenient. And then this here is 2 meters. And we want to know what is the magnitude of the force? What is that force there? And it's a gravitational attraction, so that the equation that we're going to use is Fg is equal to universal gravitational constant mass 1 mass 2 over the separation squared. So we can write that, and then we're just simply going to put in numbers here. So Fg is equal to, let's leave big G by itself, that would be 12 times 1 over 2 squared, which equals, that's going to be equal to 12 over 4, that equals 3g newtons. And certainly when I'm writing questions for a test, I have no problem with people leaving a gravitational constant in there. So that would be this guy. If you always leave the gravitational constant in there, you don't get a feel for how big these values are. And so I think every now and then it's worthwhile actually working things out to completion. So for example, if I wanted this in just a numeric value, it would be Fg is equal to 3 times, and then the gravitational constant is a really small number. It's 6.67 times 10 to the minus 11 is the gravitational constant. So that works out to be, 20.1 times 10 to the minus 11 newtons. So visualize it. If you have a 12 kilogram mass and you have a 1 kilogram mass and they're 2 meters apart, 6 feet apart, then what you'd see is that it's a tiny force of gravity attracting them. Then the next part of the question is, well, what is the magnitude of force? What magnitude of force does the 1 kilogram mass exert on the 12 kilogram mass? So now it wants this guy. And there's a conceptual underpinning here, and the misconception is often that little things pull big things weakly and big things pull little things strongly. And so it's tempting to make, the force caused by the 1 kilogram mass a tiny one in comparison with the force caused by the 12 kilogram mass. But if we think back about our basic understanding of forces, forces always come in pairs. They always mediate between two particles, two objects, and they're always equal and opposite. So the fact that this is an action-reaction pair, if you like, means that if the calculation one way is 3g newtons, then the calculation for the reaction force is 3g newtons. So just a conceptual underpinning there. There we have it.